Our second example is a little bit more complicated than the first one. In this particular case, we have what we call a double factor or a double root. Now this is going to result in something a little bit different than the previous graph. As before, we can find the y-intercepts by letting x equal 0. So we're going to have minus x, I'll use a darker colour, minus x plus 1, x minus 1 all squared equal to 0. Once again, by the null factor theorem, one of these two things must be equal to 0. So either x equals minus 1 or x equals 1. Now, this is a bit odd because last time we had 3 x-intercepts. This time we've only got the 2. And the reason we've only got the 2 is because of this squared here. Okay, that squared means there's an x minus 1 times another x minus 1. And because of that, where we normally have 2, we're gonna those two solutions are going to end up being lumped into one. And when you've got a double root like this, okay, something squared, there are two options. Okay, either it comes down like this at that point, or it goes up like this at that point. But either way, the curve, instead of crossing at that point, it just kind of bounces off the axis. The other one will be a normal one. It'll either cross like this or it will cross like this. This is very similar to the idea with quadratics, where if you had a root squared, you would have it just turn around exactly on the axis rather than crossing over it. So we've got to decide which way this graph is going to go, and we don't have that many clues to help us. Something we can do, though, is find the y-intercept. I just totally realized that actually I labeled this wrong. We've been finding the x-intercepts, not the y-intercept. And we let y equal 0. So apologies for that. If you were just confused for the last little bit, you might want to rewind and have a look at that again, realizing that I made that mistake right at the beginning. But we'll have more clues about how to sketch this if we find our y-intercept now and let x equal 0, which is what I originally wrote. So let's do this. We'll make it 0 plus 1, 0 minus 1 all squared is what y is equal to. Excuse me. This bracket here is 1, so I've got minus 1. Now 0 minus 1 is minus 1, and then I've got to square that. So this is minus 1 all squared, which is 1. So I'm going to end up with negative 1 here. So this graph must cut at minus 1. And that's actually enough information to be able to get what this curve is going. We know it's got to bounce at this location, so it's either going to bounce like this or like that. If it bounces like this, it can't turn around and cut this point. So it's going to have to be one that looks like this. It's got to bounce like that. And it goes up like that. So this one is actually going the opposite way to the other one. Remember, our first one was kind of generally increasing like this. This is an example of a cubic that's going the other way. It's coming down first. And we could actually tell that by looking again at the coefficient. Much like with quadratics, that minus sign makes it go the opposite way to what we would expect. So this is the sketch of y equals minus x plus 1 times x minus 1 all squared.